Welcome back from the ad break. Before the ad break, we went through some basic calculus. We did first principles and we did calculus using the rules of differentiation. Now, you're going to be guaranteed to get those type of questions. So you'll always get one with first principles and you'll always get one where you use the rules. Now we're going to take it a step further or step up, where we start applying calculus to other types of examples. So let's look at this question. Given that f at x is equal to negative 2x squared plus 1, determine the gradient of the graph at x equal to negative 2. Now the gradient, we know this is m from algebra, but the gradient is also equal to the derivative. And once you know this, you can actually attempt this question. Let's do it. So now, let's first find the gradient. That's our first step. So we find the derivative using the rules. 2 multiplied by negative 2 is minus 4x. And then remember rule 3 there says that the derivative of a constant is 0. So this would then be 0. Now, let's find the derivative at x equal to minus 2, which is the same as this. So f dash negative 2 negative times a negative is a positive. So our gradient at x equal to negative 2 is 8. As simple as that. Let's look at another question. Now this question says, given that f at x is equal to negative 2x squared plus 1, determine f at minus 2, not f prime, f at minus 2. What does your answer represent? So now let's find f at 2 first. This means that x is equal to minus 2. So for every x that we see in this question here, we substitute it with minus 2. So negative 2 minus 2 squared plus 1. And if you do that on your calculator, you'll just get, that's 4 times 2, 8. That's, let me write that again for you, 9. Now guys, at this step here, you don't need to put any intermediate steps or any steps in between, like 2 times 4 plus 1, because you can just go punch this straight into your calculator and you'll get the answer, and that's it. So then the second part of the question says, what does your answer represent? Now this answer here actually represents the y coordinate of this point x. So this is the y coordinate. In other words, it's the point negative 2, 9. So this 9 is the representative of this x. Now we know what it represents. So next time you get asked, find f to the 3, and your answer would then be the y coordinate. Let's now look at a different type of question. It says, given that f at x is equal to negative 2x plus 1, determine the average gradient. We've seen these words before, right? Of f between x equal to 2 and x equal to 4. Now, average gradient. We know from previously that gradient, which is m, is y2 minus y1 over x2 minus x1. And this formula we use very common in algebra, in analytical geometry, and now here. So let's now find f at the first point, because we need to find our y coordinate that corresponds with that x, right? So f at negative 2. So for every x we see in here, we substitute with negative 2. So then you have negative 2 times negative 2 squared plus 1. Now we did this previously because then we got 9. Now we do the same for 4. Now this would give you 16 times 2 is negative 32 plus 1, negative 31. So we've halfway there, we get in there. Now we need to go back and find the answer. Now we have 2 points. Our first point is negative 2, 9. Our other point is 4, negative 31. Now we can find the gradient. Because, as I said earlier, that's y2 subtract y1 over x2 subtract x1. So this is x1. I always label them so I never get them confused. I suggest you do the same too. That's x2, y2. So let's continue. Let's just take it up so we can still see our coordinates. There we are. So that's minus 31 minus 9 over 4 minus 2. Don't forget to put the bracket there, because if you don't put the bracket, you end up having a positive, and having a positive is not going to give you the correct answer. Let's continue. That would give you negative 40, and that would give you 6. Now, this obviously isn't in simplified form, so we have to get it in simplified form. Let's simplify that. That's 3. 2 can go into both ways, so that's 3. That's 20. So your answer is negative 20 over 3. And that's your gradient. Now, guys, if you get an answer that's a fraction, don't panic. It might be correct. Just go back, retrace the steps, and if you get the same answer, then you're right. Now, before we move on to the next question, I need to explain to you the difference between average gradient and gradient at a point. Now, the previous question that we did, so we had a parabola, and this was your y, and this was your x. The previous question asked you for a gradient at a point x equal to minus 2. So if, say, this was minus 2 here. So we were looking for then a gradient at that point there, if I had to draw a little graph there. So we were looking at a gradient at this particular point where x is minus 2. Now with this question that we just did, it was a gradient between 2 particular points, and the 2 points that we had were these 2 points. So if we go back to our sketch, the gradient between 2 points would be, say, a point here and here. And we'd have to find this gradient between these 2 points. So this is average gradient, this is a gradient at a point. So do not confuse the two. But a tip I'll give you is that when they ask you for the average gradient, they usually will give you 2 points, either 2 x points or 2 coordinates. And if they ask you for gradient at a point, so that's 1 point. Let's go on to the next question. Now this question is a bit more complicated, so we've raised the bar a bit up. Now this question wants you to apply not only your differentiation rules, but your exponential rules too. I'll quickly make a recap of what are the exponential rules so that we can actually apply them to the question. Let's look at them. Now it says, determine the following, leave your answer in positive exponents. Now this is important. You need to follow the rules. One thing I always do after answering a question, I ask myself, have I answered the question? Read the question again and then see if you've really answered the question. So here's this question. It says d at x. Now this is the same as saying find the derivative of 1 over square root x, x cubed minus 2x squared plus 3x. Now this bracket means you need to apply the derivative to this whole question. Let's first start with this. Guys, also notice my notation. I carry down the d of x until you find the derivative, then you drop it. So this rule here, remember the exponential rule that says x m root n. Now this rule, we can actually say m divided by n. So it's the inside of the root divided by the outside of the root. So applying it to this question now. The inside of the root is 1, and remember square root is 2. We never write the 2 down, but we know it's a 2. So x to the power of a half, x to the 3, now let's use our other rule that we did previously, where we take it upstairs. So we take this up and becomes a negative. So that's x to the negative half, x cubed minus 2x squared plus 3x. Now let's go multiply this x to the negative a half into every single term inside the bracket. There, there, and there. Let's just take it up more. So then you'd have this rule. You remember the exponential rule that says if you multiply same bases, you add the powers. So in other words, here, where we multiply in the same bases, we'd add the powers. So we'd have negative a half plus 3 minus 2 x squared plus negative a half, or rather let me just write it as negative a half first, plus 2, then plus 3x negative a half plus 1. Remember invisible 1 there. Do you notice how I'm still carrying down my d of x? I'm not dropping it, not yet. Add those two, you get 2.5. So 2.5, you can write it as 5 over 2 or 2.5, whatever suits your fancy, just as long as you understand how to do it. There is 1.5, which is 3 over 2. And there is a half. Now my reasons for actually writing my powers as improper fractions rather than mixed fractions, because then it's easier for me to use the rules when I differentiate, because then I don't have to convert back into an improper fraction. I've already got an improper fraction mode, so I can just continue. Let's go into the next one. Now let's use our rule. So we're going to multiply this. Remember there's an invisible 1 there. So when I use the differentiation rule, what do I have to do? I drop the d of x. That's 5 over 2x. Subtract 1 from there, you get 3 over 2. Multiply that into there. You can crunch it into your calculator. You get 3x to the power of a half. And into there, we get plus 3 over 2 x to the negative a half. There. Now we look at our question. Remember the question said, leave your answer in positive surds. Do we have positive surds all the way? No, we don't. This is a negative surd, so we need to convert that. Remember, how do we convert? We take it downstairs. And that is the end of our question. This question is very extensive, but once you do it step by step and slowly, and you apply all your exponential rules correctly and your rules of differentiation correctly, you should get to the end of it. So try some more, practice, and you'll get there. Now let's go to an ad break, and when we come back, we'll go into another calculus question. Fun with calculus.